Hi students, welcome back to Lectures Club. Today we are going to talk about an important member from the family of transistors, which is junction field effect transistor. As you can see, the JFET extremely looks like, entirely look like BJT from the outside, but from the inside the JFET is different as compared to bipolar junction transistor, and the working of JFET is different as compared to bipolar junction transistor. The working principle of a field effect transistor. Basically, JFET comes in a field effect transistor family. The working principle of field effect transistor is that in a field effect transistor we control the resistance of the overall component, or you can say the channel from where the current passes. We actually control the flow of current by varying the electric field. With the help of electric field, what we do, we control the flow of current, we increase the flow of current or we decrease the flow of current with the help of an electric field. We will talk about on it later on. The types of field effect transistor. One is metal oxide semiconductor field effect transistor, where I have already discussed on this. You can watch my lecture on MOSFET. And the second one is junction field effect transistor, which is our prime topic today. The contents of today's lecture are: first we will discuss what is a junction field effect transistor, then we will study the construction of JFET and the working principle of JFET, and at the end of the lecture we will discuss two important terms: pinch off voltage in JFET and cut off voltage of JFET. So let's start our today's lecture. So now, what is a junction field effect transistor? Like BJT, JFET is also a three-terminal device. One terminal is source and one is drain, and the last one is the gate terminal. So in case of JFET, as we just talked about the function of JFET, in JFET we control current with the help of electric field generated around the reverse bias depletion region of the PN junction. If you remember, in BJT we used the depletion region to control the flow of electrons or to control the flow of current. In fact, we make or break these junctions, the emitter base junction or collector base junction, we make or break these junctions to control the flow of current through the BJT. But here we will not make or break any junction. In fact, we will use the already built-in junction, the width of the junction, or we will use the electric field of the junction to control the flow of current. This is the working principle of JFET. In JFET, what we do, we use the PN junction to control the flow of current, or we use the width of the PN junction or the electric field of the PN junction to control the flow of current, or to increase or decrease the flow of current through the transistor. The construction of JFET. Let's say we have a slab of N-type semiconductor material. We have a piece of N-type semiconductor material. We connect two terminals on its opposite sides, you can see, and then we do doping of P-type material inside the body of N-type material, something like this. And we connect these two P-type layers with each other. So this terminal is common to these two layers, and these terminals are called source, drain, and the gate. The gate is common to both of these P-type layers. This is example of N-channel JFET. If we do the opposite, then it's a P-channel JFET. Here you can see that we did doping of N-type material inside the body of a P-type semiconductor material. So why we call this N-channel JFET and why we call this a P-channel JFET? You can see that a way or a channel is being created between these two layers. Similarly, a channel or a way is being created between these two N-type layers, and this channel between these two layers, p-type layers, is made of n-type material. So this is called n-channel JFET, and this channel is made of p-type material between these two n-type layers. That is why it is called the p-channel JFET. These are the symbols of n-channel JFET. You can see that the arrow is going towards the body of the JFET in case of n-channel JFET, and here the arrow is coming out of the body of the JFET. So when we did doping of p-type material, and similarly we did doping of n-type material. So definitely if there is a n-type material and p-type material, definitely there should be a p-n junction. When we did doping of this p-type material and this p-type material, a junction is being created, p-n junction is being created between this n-type layer and this p-type layer. The junction is shown by the dotted lines here. Similarly, when we did doping of n-type material inside the body of the p-type material, a semiconductor, the p-n junction is being created between these two semiconductor layers, n-type layer and the p-type layer. The working principle of JFET. We just talked about the working principle of a field effect transistor, but here we will discuss the working principle of junction field effect transistor. The flow of current basically depends upon the width of these two p-n junctions. The flow of current will increase or decrease when we will vary the width of these p-n junctions, or in other words, we will use the electric field of these p-n junctions to control the flow of current. And how we do, we will talk about on it in the coming slides. But here I tell you, we actually control the voltage between potential difference between the gate and the source. By varying the potential difference, gate to source voltage, we actually control the width of the channel, and hence we control the flow of current between the drain and the source. So the working of JFET depends upon two conditions. The first condition is the gate to source voltage is 0, and the second condition is gate to source voltage is lesser than 0. We do not give the positive voltage at the gate, because what will happen when we give the positive voltage at the gate and lesser voltage at n-type material, so this junction will be forward biased. We do not want to break the junction. We will use the built-in junction to control the flow of current. Basically, we use the negative voltage at the gate, but for the sake of simplicity, to understand the working of JFET, we started by using the 0 voltage at the gate. So gate is at 0 volt and the source is also 0 volt. At 0 volt, it means the gate and the source both are grounded, and we used a variable 5 volt, 0 to 5 volt between the drain and the source. So when we applied 5 volt between the drain and the source, what will happen? The electrons will start moving from the drain towards the source. Another important thing to notice here, drain is connected to the positive terminal of the battery, and source is connected to the negative terminal or 0 volt. Source is at 0 volt. So potential difference should be there to the flow of current between the drain and the source. Drain is at the 5 volt, and then some potential drop will take place, and let's say at this point the voltage is 4 volt, and then further voltage drops. Let's say at this point voltage 3 volt, at this point the voltage is 2 volt and 1 volt, and so on. So potential difference is taking place between the drain and the source. Second important thing to notice, that because of this potential difference between the gate and the drain and the gate and the source, change in potential difference basically impacting the width of the p-n junctions. The p-n junction is expanded more towards the drain and less towards the source, because the potential difference towards the source is decreasing. You can observe here is 5 volt and here is 0 volt. So potential difference is high. 5 minus 0, 5. Here is 4 volt, here is 0 volt. Potential difference is 4 minus 0, 4 volt. 3 minus 0, 3 volt. 2 minus 0, 2 volt, and 1 minus 0, 1 volt and 0 volt. So what will happen? When the potential difference is higher, definitely this reverse bias p-n junction will increase, and it will increase more towards the drain and less towards the source. and this shape is shown by the dotted lines. Here you can observe that these two p-n junctions are expanded more towards the drain and lesser towards the source. When electrons will enter into the body of the JFET, you can see a large number of electrons have been entered into the body of the JFET, but these electrons want to go towards the drain because this is the proper way. Electrons are moving from the negative towards the positive. But here these junctions have been increased. The width of these p-n junctions have been increased, and the path between these two p layers have become narrower. Electrons do not have much width to flow between the gate and the source. If we increase the voltage or decrease the voltage here, definitely this p-n junctions will increase or decrease. More potential difference, more increase of in the width of the depletion region, less potential difference, so less the width of the depletion region. When we increase or decrease the width of the depletion region, electrons will flow between the drain and the source, but a few number of electrons will manage to flow between the drain and the source. So when we decrease the width, more electrons will flow between the drain and the source, and we will increase the width, lesser electrons will move between the drain and the source. So here what we are doing, we are not making or breaking any p-n junction. We are using the same p-n junction, built-in p-n junction. We are changing the width of the p-n junction, and we are controlling the flow of current or flow of electron by the effect of electric fields of these two p-n junctions. So that is why it is called a field effect transistor. But we are using the electric field of the junctions, so that is why it is called a junction field effect transistor. So here we are controlling the flow of current. We are increasing or decreasing the flow of current by changing the width of the channel. If we increase the width of the channel, definitely what will happen, the more current will flow, and if we will decrease the width of the channel, so lesser current will flow between the drain and the source. So now the gate to source voltage is lesser than 0. This is the second condition. Actually this is the proper way how we operate the junction field effect transistor. In the previous slide we assumed that the gate to source voltage is 0, just for the sake of understanding the proper function of JFET, but this is the proper way to operate a JFET. We apply the negative voltage at the gate. When we apply the negative voltage at the gate and the positive voltage at the drain, the concept is the same as previous. When we keep on increasing the potential difference between the gate and the drain, what will happen? The width will increase towards the drain and width will decrease towards the source. When we keep on increasing the potential difference, definitely the width of these two junctions will increase and the width of the channel will decrease, so electron will reduce. Now what is the pinch off voltage? Let's say we are increasing this gate voltage, we are going more and we are going towards more and more negative side. So these two junctions will keep on increasing towards the drain and will keep on decreasing towards the source. What will happen? A point will reach when these two junctions, this p-n junction, junction of the left side as well as junction of the right side, they will become so close to each other, but they will not contact with each other. They are so close to each other, but they are not contacting each other because of the electric fields. Because of the electric fields, they are still repelling each other. They are not contacting each other. But at this point, when you further increase the potential difference, the width of the channel is not decreasing because these two p-n junctions, the electric fields of these two p-n junctions are repelling each other. So what will happen? The path of this channel is the narrower or is the smallest, the width of this channel is the smallest of all times. At this point, the further decrease of current will not take place and current will become constant. At this point, the JFET has entered into saturation region and further increase in the potential difference will not decrease the width of the channel and current become constant. At this point, the JFET has gone into saturation region and this is called the pinch off voltage. So now what is the cutoff voltage or VGS off? You further keep on increasing after the pinch off voltage, you further keep on increasing the gate to source voltage. A point will reach when these two p-n junctions will completely block this channel. They will become more close to each other. At this point, this junction, I mean the junction of the right side and the junction of the left side, they will become so close to each other, they will completely block this channel. At this point, the JFET will go into the cutoff region and no current will flow through the JFET from the drain towards the source. I hope you have understood all the necessary concepts to which were necessary to understand the working of JFET. If you like the video, kindly subscribe my channel. So next time I will come up with more videos on electronic devices. Hopefully I will make the next video on the characteristic curves of JFET and what is the transconductance of JFET. Thank you so much. Bye bye. Stay blessed.